All right, folks, welcome to the show. Today we're diving into a subject that's not just out of this world, literally, but also reshapes our understanding of life itself. We're talking about life in extreme environments, or as I like to call it, the wild world of extremophiles.
It's incredible, really.
Microorganisms are thriving in places we'd consider uninhabitable, like boiling acidic springs and deep-sea hydrothermal vents. How do these critters survive where we'd just evaporate or get crushed?
That's insane. Wait, so, these tiny organisms can survive in, boiling acid? How does that even work? I mean, do they have superhero powers or something? Or is it more of a survival of the fittest situation? Laughs.
Haha, it might sound like they've got superpowers. But really, it's all about molecular adaptations. For instance, let's take Pyrolobus fumari, a microbe that thrives in temperatures up to 113 degrees Celsius. Their proteins are specially stabilized so they don't denature, which is basically what happens to proteins when they get too hot and fall apart.
Ooh, so they're basically like little microscopic heat shields? Wow. But what about those deep-sea critters? You mentioned Shewanella benthica, right? How do they deal with all that pressure?
Exactly. They are like nature's own submarines. At depths that would crush a human, these microbes have unique cell membranes and structures that prevent them from collapsing under pressure. It's fascinating because their adaptations offer insights into possibly finding life on ocean worlds like Europa, one of Jupiter's moons.
Right. So do we think that life could actually exist out there in those oceans? Like, if we found an alien jellyfish or something? Not just bacteria? That'd be crazy.
Haha, imagine that. Alien jellyfish. But yes, that's the possibility we're examining. Take black smoker ecosystems, for instance. They rely on chemosynthesis instead of photosynthesis, which is the process most life on Earth uses. Instead of sunlight, they draw energy from chemicals released by these hydrothermal vents. So, if something similar exists on Europa, where there's likely an ocean beneath ice, who knows what we might find?
That's just mind-blowing. So, what about those volcanic systems? You mentioned they might be a good model for Martian environments. Are there, hot springs on Mars, too?
Yes, you'd think they're not possible, but Martian geothermal deposits are a hot topic, pun intended. Acidic hot springs could harbor microbial life if it exists. And those lava tubes on Mars? They're excellent analogs for exploring potential habitats. Imagine Martian cave systems with microbial communities just waiting to be discovered.
Whoa, so Martian adventures in caves? Not to be dramatic, but that sounds like a movie I'd watch. So then, how do these extremophiles affect our thinking about extraterrestrial life in general?
Great question. Extremophiles expand the habitable zone, the regions where life can exist. They teach us to look beyond Earth's conventional environments. For instance, Antarctic subglacial lakes are cut off from sunlight but are still teeming with life after being isolated for thousands of years. If microbes can survive there, what's stopping life in a dark, warm ocean beneath ice on another planet?
Wow, so, if life can persist in some of the harshest conditions on Earth, then it's possible, anywhere? It's like a cosmic game of hide and seek. So what's the next step for scientists studying these organisms?
Well, that's where it gets exciting. We're developing advanced technologies to detect biosignatures on Mars. Think of it like creating a cosmic fingerprint scanner. We must also establish planetary protection protocols to ensure we're exploring safely and responsibly. After all, we want to discover life without contaminating other worlds.
Oh, definitely. It's like leaving the party without trashing the place, right? Laughs. So I guess the real takeaway is that life can thrive in extreme situations, which is making our search for extraterrestrial buddies a lot more intriguing.
Exactly. Extremophiles are redefining what we know about life's limits. It's a thrilling era for astrobiology. And who knows, we may soon find life in places we never thought possible. Imagine all the possibilities scattered across the universe.
I'm all for it. Just, no alien jellyfish, please. They sound a bit, I don't know, tentacly. Haha. But I'm super excited to see where this research leads.